Don't forget to subscribe and ring that bell.
What a beautiful day. A beautiful day for some calculus. Let's go. We are going to continue the 2018 AP Calculus AB practice exam that College Board put out a little while ago. And we are going to start Section 2, Part B. There are 4 questions, and on none of them am I allowed to use a calculator. Ew, gross. But you know what? When we don't get to use the calculator, the math is typically easier to calculate because you don't get a calculator. We are going to start with free response question number 3, which is the first of 4 questions in this section. So, hey, without any further ado, let's begin. Number 3. Oh my God, did they give us a graph? Guys, oh my God. Stay calm, act cool, act like we've been here before. They gave us a graph. You know how I feel about graphs, tables, and charts. I love them. Number 3, the function g is defined on the closed interval from -4 to 8. The graph of g consists of 2 linear pieces and a semicircle, as shown in the figure above. Let f be the function defined by f of x equals 3x plus the integration from 0 to x of gt dt. 3a is asking us, or really telling us, to find f of 7 and then find f prime of 7. So we will do this in 2 steps. First, let's find f of 7. Okay, here. Let's start with a nice green. Okay, f of 7. If I'm going to find f of 7, that means I'm going to plug a 7 in for any x in my function right here. I have 2 places where there's an x. Here next to the 3, and here in the upper bound of my integral. So that's going to be 3 times 7 plus the integration from 0 to 7 of g t dt. Now, this part's easy, kids. It's 21. See, I told you without the calculator, the math is going to be easy. You didn't want to believe me. That's because you have a fear of math, friends. This second part, however, I do not have an equation for g of t that I'm going to add to 21. But I should know that an integral is the same thing as area under, wait for it, the curve. It's the area under the curve from my lower bound 0 to my upper bound 7. Wow, this looks really strange using the same color all the time. Normally I try and change it up. Anyways, here's 0 on the x-axis, and here's 7 on the x-axis. So why don't I just do this? Well, let's get fancy. 0 to 7. I need the area under the curve of this thing right here. All right? So I really have 2 parts that make up the area under the curve. Oh, I get to use the highlighter so early on. I have this semicircle portion right here. And then I also have this kind of this rectangle right there. And when I say kind of a rectangle, I mean it's really a rectangle. But let's keep something in mind. When I integrate something, okay, any area that is above the x-axis, okay, and this is the x-axis, okay, any area that's above the x-axis is going to be considered positive value, and any area underneath the x-axis is considered negative. So this right here is going to end up being a negative area. Whatever area I get, I need to make that negative. And whatever area I get here for the rectangle should be considered positive. All right, so let's figure those out. First, let's start with the rectangle, because that's easy. It is a width of 1 and a height of 3. Okay, let's make sure our units go up by 1, and they do. Okay, and they go over by 1. So it's 3 by 1. So the area of this rectangle is base times height, which is 3 times 1, which is 3. Okay? That's a positive 3 right here. Positive 3 for this area right here. Semicircle. The area of a circle is pi r squared. But keep in mind, we have a semicircle. So technically, we have half of a circle. So I'm going to multiply it times a half. The radius from 3 to 6 is also 3. All right? So it's 1/2 pi times 3 squared. Okay? 3 squared is 9. So I'll put 9 over 2, because 9 times a half is 9/2. Pi. This is the area of the circle. How come I don't calculate pi times 9 over 2? Because I don't have a calculator, so I'm not going to take 3.1415926 and multiply it times a fraction. Okay? That is an exact answer. You do not get a calculator. And I tell you what, if you give them an exact answer, they will be happy. But keep in mind, since this is below the x-axis, this value needs to be negative. This is the area here. So if I want the entire area from 0, yep, there you go, from 0 to 7, I've got to combine the area of the semicircle and the area of the rectangle. So let's go down here. The area of the semicircle, I should do that in red, was negative 9/2 pi, and the area of the rectangle was 3. Okay, the only thing I can combine here is 21 and 3. That gives me 24 minus 9/2 pi. That is a good evaluation of f of 7. Okay, and keep in mind, we are only halfway done with this first problem, because now, my friends, we need to find f prime of 7. Okay, so let's break this up. And we have f prime of 7. First, before we plug a 7 into the derivative, let's find the derivative of f of x. I'm going to take this bad boy and take the derivative of that equation. So first, I need to take the derivative of 3x, which is just 3. Plus, I need to take the derivative of the integration from 0 to x of gt dt. Now, wonderful thing happens when you take the derivative of an integral. They kind of cancel. Like this cancels with the integral, and when the integral goes bye-bye, so does the dummy variable. And what's left is, whatever the upper bound is, I put in for my t. So really, it's plus g of x. Now, the chain rule applies here, which means I really, after I get this, got to multiply by the derivative of whatever this upper bound is. Okay? The derivative of x is 1. So technically, I got to multiply that times 1. But anything times 1 is itself. So we really don't need to put that there. All right? So this is the derivative of f of x. They want this at 7. Okay? Remember, 7. So there's no x here. That's going to be 3 plus g of 7. This is nice because this is just a coordinate. That is a coordinate. So basically, when x is 7 in my graph of g, what's my y? All right, let's see. Let's go up here. Ooh, I got a big fancy line through there. All right, so let's, you know what? Let's get this out of here. Let's clean this up a little bit, so it's a little easier. Let's clean this up a little bit. I like making this big mess. I'm a messy person. Okay, there you go. Get rid of this. Now it's nice and clean. It's even better when I do this. Whoa, that's not what I wanted to do. Bye-bye. At 7, when x is 7, where's my y? It's this point right here. Boop. That coordinate is when x is 7. My y is 3. There you go. There's my point. G of 7 is 3. That means this thing is 3. 3 plus 3. I told you the math of the calculator. It's not that difficult. Is 6. So f prime of 7 should be 6, and it is. And we're done with the first part. 3b. Find the value of x in the closed interval from -4 to 3 at which f attains its maximum value. Okay, justify your answer. First, let's differentiate. No, I don't mean take the derivative. I mean, we will get there. But let's determine, I should say, what they're asking us. Find the value of x in the closed interval at which f maintains its maximum. A maximum is a point. Okay, you have an x and a y value. The x is where it occurs, or the location, if you will, and the y is actual value of that maximum. We do not need the y, we only need the x where it occurs. This is what we're looking for. Where does it happen? Okay, because a lot of questions they ask you for the value. What is the maximum? And people will give the x as the answer. But the actual maximum value is the y, and the x is the location of where it occurs. All right? Bam. That's established. Second thing, I said we're going to differentiate. But in order to find mins and maxes, okay, I need to use the first derivative. I need to differentiate f. In the first problem, they give us the derivative of f already. Okay, they give us the derivative of f, don't they? The derivative of f, which we solved for, okay, highlighter, so it pops out. The derivative of f, before I plugged in my 7, was 3 plus g of x. Remember, oh, so long ago when we tried to figure out what f prime of x was, we took the derivative of this, and I got 3. And I took the derivative of this, and it was just g to the x. So the derivative of f of x is 3 plus g of x. So I'm going to go over here. And I'm going to say, for my own sanity, that f prime of x is 3 plus g of x. Okay, this means I'm going to need the graph of g of x because I don't have an equation for g of x. So let me do this. I already copied this, paste this. Oh my goodness, that is ginormous. Let's do this here. Right here, this is good. It's a good little view. All right, this is the graph of g. The derivative of f is the same graph. Okay, it's the same graph plus 3. If we know anything from Algebra 2, we know that when we add a number outside of a function, meaning if I have g of x and I add a number outside it, this just tells me that this graph is moving up 3 units everywhere. So watch what I'm going to do. We'll do this in, I don't know, orange. My interval is -4 to 3. So from -4 to 3, this part of the graph right here, okay? This in red. -4, this part of the graph that I'm going to just trace in red, okay, starts here and ends here, okay? I'm going to take that whole graph and move it up 3, all right? So if you keep an eye on this point right here, we'll just move it up 3, okay? 1, 2, 3. This graph that I have right here in red is g of x moving up 3, which means that graph in red is really f prime of x. Okay? Now keep in mind, all right? We're going to get rid of this right here. I don't need this anymore. That's not even coming into play. This graph now is the derivative of f. So my y is the derivative of f, which means anytime the y value is positive, the derivative of f is positive. How do I know? Because y is f prime. Anytime we are above the x-axis, okay, we have a positive y. If we have a positive y, we have a positive f prime. So f primes are positive above the x-axis. Anytime we're below the x-axis, my y values are negative, which means my f prime is also negative. Where do we attain its max? If we start at -4 and go to 3, all right, highlighter. If we start at -4, and then we keep on going and go to 3, notice that my graph is always above the x-axis, which means my first derivative is always going to be positive. And if my first derivative is positive, that means my slope is positive. Let me say that one more time. If my derivative is positive, that means my slope is positive. That means if I start at x equals 4 and I constantly have a positive slope, or -4, and I constantly have a positive slope until x equals 3, the maximum is going to be at x equals 3. Okay, so that's going to happen at x equals 3. And that, my friends, is our answer. And the explanations normally take longer than the work. So some of these problems that take a long time, it's because I'm really drilling some of these points that you really need to know to be successful on the AP Calculus AB exam. 3C. C is for coffee. Nice warm coffee. By the way, if you are a coffee connoisseur like I am, I love peppermint mocha during the holiday season. I like mocha lattes. I got a little bit of a sweet tooth. But Coffee Mate makes the best creamer in the world. Their peppermint mocha coffee creamer. It's Coffee Mate. Don't get International Delight. Don't be fooled that they put Will Ferrell on the cover in his elf outfit, because the cover is cool for International Delight, but the creamer doesn't taste the same. It tastes good, but Coffee Mate's brand of peppermint mocha, especially as we approach the holiday season, love it. Anyways, C reads, for each of the limit as x approaches 0 from the left of g prime of x, and the limit as x approaches 0 from the right of g prime of x, find the values or state that it does not exist. All right, let's point out the obvious. This is a graph, and notice I had it up here. I didn't have to paste it while we were doing the problem. This is the graph of g. Okay, look at the bottom here. Well, we're taking the limit of g prime. So let's establish one very common sense thing we should know. G prime is the derivative of g, correct? And we know that the derivative is the same thing as slope. So if I really want to know g prime in this graph, I'm just looking at the slope of g. This is g. I'm just looking at the slope. Now keep in mind, we'll do this nice soft blue. The limit as x approaches 0 from the left of g prime of x. Okay, so what's the slope of g as we approach 0 from the left? That's really what they're asking. Okay, and 0, in case y'all didn't know, origin, right there. That's where x equals 0. Okay, so as I approach 0 from the left, basically this is a line. So really, we just want the slope of this line right here. Okay, we just want the slope of that line right there. And this is really just, I mean, we're just counting. We go down 1, and we go right 2 to the next point. Down 1, right 2. Okay, so if I move down 1 and right 2, that means the down is negative. All right, well, boom. The answer to that first problem is -1/2. Simple. I mean, that was 8th grade math stuff. All right. And now, okay, that's done. We need to find the second one. And let's go back to that soft blue. It's very pretty. We need to find the limit as x approaches 0 from the right of g prime of x. Okay, same deal. But here's the issue. I'm approaching 0 from the right, so here's the right side of the graph. Look what happens as I get closer and closer here. What is that? What is the slope as I get closer to here? Guess what it looks like? Guess what it actually ends up being? A vertical line. A vertical line does not have a slope. It's undefined. There are 3 occurrences where a graph that is continuous is not differentiable. A corner, not differentiable. A cusp, not differentiable. Or anything that has a vertical tangent line, not differentiable. Okay? It doesn't exist, the slope. Does not exist. Or you could do that 0 with the line all the way through it, or you can write the words does not exist, or it's undefined. They really want the value. So the value, I guess we would have to say undefined. That might be the best one to go with. If it was asking me for like a asymptote, I would say it does not exist or whatever. But undefined might be the one I went with, although I think any of them would be acceptable. But undefined is the one that is, in my mind, unquestionably correct. So find the value or state that it does not exist. I guess stating it does not exist would also make this 100% correct. It does not exist. Why? Because it's approaching, because as I approach 0, right? It's approaching, wow, that just was weird how it popped up there. It's approaching a vertical line. Therefore, it's undefined slope. It doesn't ask for the explanation, does it? I just like sounding smart, and you should too, because you are smart. One more part for Mr. Smart. The final part of 3D, find the limit as x approaches 2 of f of x plus 7 all over e to the 3x plus 6 minus 1. Okay, so first of all, it might be handy-dandy if we had our graph here. I don't know. I'm just going to paste it here. Oh, my God, look what happened. We are so off here. Let me get that. I'll be right back. Boom. There we go. We're back. All right, so the easiest way to do this, always the easiest way to do this, is to try, okay, to try plugging in -2 first. So let's just do that right there. Okay, so we're going to take f of -2 plus 7, put it over e to the 3 times -2 plus 6 minus 1. All right, so in order to find f of -2, remember on part A, they gave us the equation for f. They said f of x is 3x plus the integration from 0 to x of gt dt. Okay? Don't know why I put parentheses around dt. So if I want to find f of -2, that's going to be 3 times -2 plus the integration from 0 to -2 of gt dt. Now keep in mind, I'm going to scroll down here instead of keep on writing at an angle. This gives me -6 plus, I want the area under the curve of gt, okay, from 0 to -2. So let's look at our graph. Oh boy. From 0 to -2. All right. So here we go. Here's 0. Here's -2. So this little triangle right here, it has a base of 2 and a height of 1. That is 1/2 base times height for area of my triangle. So it's 1/2 2 times 1, which is really 1. Okay? And in fact, I'm going to make it -1. How come? How come that should be -1? Look at my bounds. You see how the lower bound is up top and the higher bound is on the bottom? I need to flip those. I need to put the -2 and the 0 here. Okay? When I flip those, I need to negate whatever my answer is. Normally, before the negation, I just got 1. But since I flip my bounds, that becomes -1. Okay? When I combine these two, I get -7. F of -2 is -7. All right, so let's go up here. This is now, we put -7 here, plus 7 over 3 times -2 is -6 plus 6. Okay, that's e to the 0 minus 1. We get 0 over anything to the power of 0 is 1. 1 minus 1 is 0. Whenever I get 0 over 0, I can use L'Hopital's rule, which means I take the derivative of the top, and I take the derivative of the bottom, and I throw a -2 in again. So the derivative of the top, okay, is just, well, I guess I should go here. The derivative of the top would be, okay, the derivative of f of x is just f prime of x. Okay, the derivative of my 7 is 0, it goes bye-bye, over the derivative of e to the 3x plus 6 is e to the 3x plus 6 times the derivative of the exponent, which is just 3. Again, this is called L'Hopital's rule. Okay, whenever you get a 0 over 0. Now I can try throwing the -2 in again. The derivative of f at -2 over 3 times e to 3 times -2 plus 6. Okay, so the question is the derivative of f. We did that in part A as well. Woo! The derivative of f from 3a was 3 plus the derivative of the integral from 0 to x of gt dt. And when we did that, remember, these canceled, the x went in here, so really it's 3 plus g of x. That's the derivative of f. They want it at -2. So if I throw a -2 in for this x, I need to throw a -2 in for that x. Let's go off to the side here. So it's 3 plus g of -2. This is just telling me they want the y value when x is -2 on my g graph. Let's go all the way up here. At oh, I really hate when the board does that. But what are you going to do? When x is -2, here's the point. The y value is 1. Okay, the y value is 1. So, let me extend this. G of -2 is 1. So I'm going to put a 1 here. So I have 3 plus 1, which is 4. Woo! It's a lot of work. That's the top there. This top here is 4. Over 3 times -2 is -6 plus 6. That's e to the 0. That's the same as 3 times 1, which is 3. My goodness gracious. Look at the mess we've created on this board. But you know what? They say most genius is unorganized, right? Not that I'm saying I'm a genius. I'm saying you're a genius. Well, me too. I'm a genius. Anyways, 4/3. Quick review here. We tried throwing in a -2 first and got 0 over 0. Okay? We tried throwing in this -2 first and got 0 over 0. So we had to use L'Hopital's rule, which means I took the derivative of the top and the derivative of the bottom. We found out that f, and again, once we did that, we had to throw our -2 in again. We tried it. Remember, why are we trying to throw in a -2 again? X should be -2. Okay, so I throw a -2 into this derivative, and I do all of this poo-poo work to get 4. Starting for here, do all this poo-poo work. And I end up with 4. So that's that numerator. And then we just did this algebra and got our 3. 4/3. My goodness, thanks for hanging. I'll see you again when we do free response question number 4. And it'll probably be just as sloppy. We'll see you. Hey, like, follow, subscribe, leave a comment. I'll talk to you.
Don't forget to subscribe and ring that bell.